The last thing we're going to talk about in this course is this debate about whether we should be using recursion or iteration to solve a problem. I want you to think back to when we were designing algorithms for finding Fibonacci numbers. We saw that when we designed algorithms for it, we had two different approaches. The first approach used what we call an iterative control structure to repeat some set of statements. Now, an iterative control structure uses some type of looping structure, such as a while loop, a for loop, or a do while loop. But these looping structures are used to repeat some set of statements. You've been using these since CS121. The second approach used a recursive method. So what we did is we still repeated statements, but instead of using some type of loop structure, we had the method call itself to handle this repetition. We also used some type of control structure, like an if statement, to control the actual repeated calls in the recursion. So we would use the if statement to determine, do we stop calling the method or do we continue calling the method? What we see is that we can actually use either recursion or iteration to solve different types of problems. Even something like the binary search example. We showed an iterative approach earlier in the semester, and then we also showed a recursive approach for doing binary search. So the question to ask is, which one is better? Is it better to use recursion or is it better to use iteration? And the answer to that is not a simple answer. There are some problems where you may say, clearly we should use iteration. There are some problems you may say, clearly we should use recursion. But overall, the answer isn't simple. A major factor in determining whether to use one or another is the efficiency of using iteration or recursion. And here's what we mean. I think we've mentioned this before, but we're going to go over it again. Whenever we call a method, we have to allocate memory space for the parameters of that method and any of the local variables for that method. Now, whenever the method terminates, that memory space is then freed up or deallocated. Now, every recursive call is going to have its own set of parameters and local variables. And what this means is every single time we make a recursive call, we have to have the system allocate memory space for those parameters and local variables. And then whenever the method is done, we have to deallocate that memory space. And this is extra time that we need to do that allocation and deallocation. So there is some overhead associated with executing a recursive method. We have overhead in terms of the additional memory space in our system and the overhead of taking computational time to allocate that memory and deallocate that memory. And what that means is that a recursive method is going to execute more slowly than an iterative version of that solution. Now, is that a bad thing? The answer is maybe. If we're dealing with a slower computer, especially those that have a limited amount of memory space, we could see a noticeable difference. The slow execution of a recursive method could be quite noticeable. If we're dealing with a limited amount of memory space and we go too far in our recursion, we may run out of memory. So this is a big problem on older, slower computers. Fortunately, today's computers are fast enough and have enough memory. So the execution of a recursive method is not as noticeable. So it may be slightly slower than the iterative solution, but you're not going to see this huge difference between one or the other. So in this particular case, the choice between iteration or recursion is just going to depend on the nature of the problem. Some problems are easier to solve using recursion. Some problems, they're not as easy to solve using recursion. Now, there are some problems such as mission control systems where efficiency is absolutely critical. So there, the efficiency factor is still going to dictate which approach you're going to use for solving a problem. So what's the verdict between recursion and iteration? Well, as a general rule, if you think an iterative solution is more obvious and you think it's easier to understand, if you understand it better than a recursive solution, then just use the iterative solution. It is more efficient than using recursion. So if you understand how to do it using iteration, there's no need to go out of the way to come up with a recursive solution. Yeah, it may look more elegant, but we're looking for practical results, not how neat your code is looking. So if you know the iterative approach, go for it. Now, on the other hand, there are problems where a recursive solution is more obvious, or it is easier to construct. For example, there's the Tower of Hanoi problem. I dare you to try to construct an iterative solution to that problem. Go ahead and work it out and tell me how it goes. So what we're saying here is, if there are problems, well, there are problems, but if you find that a recursive solution is more obvious, then go with the recursive approach. In fact, if the definition of a problem is inherently recursive, then I would suggest to go ahead and consider the recursive solution. Now, you could do it using iteration, but if it's a lot easier to understand using recursion, then go ahead and use recursion.